Hello my students, today we are going to see another topic of ray optics, apparent depth. See, generally you can see any object is placed in the bottom of the beaker. If water is poured in the beaker, the object should be raised, but actually the object is not rising, it is appear to rise. Then a bottom, original height. Actually the height of the object when you place without water is original height of the object. If any liquid is filled with beaker, it is appear to rise. Actually it's not original height. This height is called apparent. So the depth a place inside a beaker is up to apparent depth. See, mathematically now we are going to calculate how much height, that means from the bottom, is raised to appear. Now we are going to calculate with the mathematically. See, for example, this is the beaker. This is the beaker. Yeah, object is placed in the beaker. This is the object. Suppose your eye is here. Now without water, your eye is here. We could see the object now easily. If you are moving away from the object or away from beaker, you are unable to see the object here. You are not able to see the object here. If water is poured into beaker, gradually level of the water is increased. Level of the water is increased. You are standing just the same place. You could see the object. When object is placed without water, you are aside. You are not able to see the object. But without changing the position here, when continuously your water is poured in a beaker, when the certain level of the water is rise, but you can see the object from the beaker even though you are not changing the position. Actually, without water, the body's object is placed at the bottom. When water is poured, but the image of the object is rise, but you could see the object. See, now the object is maybe in this position. You can see object. So this distance, actually this is the original distance of the beaker. Now this much distance change, let's say d prime. But actually the height of the object is d double prime. Height of the beaker is a d. Now the object could see in this position, but this much the height is a change inside the liquid. So this distance, now we are going to calculate, this is changing the distance. It is elevated. So this distance is called apparent. Apparent distance. Actually inside the beaker is apparent depth. Mathematically now we are going to calculate the apparent depth. This distance is apparent depth. Okay. Let's see. We know that from Snell's law. See, this distance changes is appear to come from this position. Actually, this is the original position of the object. When liquid is pouring, it is appear to be this distance. This changing the distance. Why? Because of refraction. Because of refraction of light inside the liquid. We know that when light travels from one medium to another medium, there may be changing the refraction. the light velocity changes, refractive index. Because of the refractive index, the velocity changes, wavelength changes, but the frequency remain constant. We will talk later why the frequency remain constant later. When a light coming from the source, suppose this is the liquid, this is the air medium. Air medium is called rare medium. Suppose a light coming from the sources incident on the surface of the liquid. Actually, the path of the liquid has to be travel like this. Instead of this, after incident on this point, refracted, just bend towards normal. This is the normal. This is the angle of incidence. This is the angle of refraction. So, light coming from one medium to another medium, bent towards normal. That means rarer medium to denser medium. But the same light passes from denser medium to rarer medium, light bends away from the normal. Away from normal. So already you have studied from the Snell's law. See, let's consider a beaker. Object is placed here. Suppose this is the object. This is the O object. You could see actually light coming from the object. Light coming from the object. Suppose light is placed in this position. Light is placed inside the liquid. So completely filled with water. Completely filled with water. This is the surface of the liquid. This is the denser medium. This is air medium or rarer. This is the air, this is the denser. So the surface separate between air medium and denser medium. It is XY. XY surface which separates between air and denser. Okay. If light coming from the source, not from the rarer medium, light passing from the denser medium to rarer medium, object is placed here, or for example this is a light or object. This is a light or object. See, one of the ray coming from the source, incident directly to the surface. Directly to the surface and refracted away. One of the rays. Another ray is coming from the source, incident on the surface. On the surface. After the incident, refracted away from the normal. This is normal. Put is n and n prime. So this is the angle of incidence. This is the angle of refraction. Light from the source at point O, incident on the surface at a point, any one other point, put it point B. It's a point B at surface. You put it is a point D. One of the ray coming from the source incident on the surface, exactly on the surface, normally. Light transmit. Here, what is angle of incident? What is angle of refraction? Angle of incident which is equal to angle, because this light does not deviate. From Snell's law, mu or n is equal to sin I by sin r. N is refractive index. N is a refractive index. We can use the notation mu or n. Mu or n. So from Snell's law, n or nu is equal to sin I by sin r. If light coming from the source at point O, incident at the point D on the surface of the liquid, which is separates between rarer medium and denser medium, angle of incidence I is equal to 0. N is equal to sin I by sin r. So sin I. So that means I is equal to 0. Angle of incidence. What is the angle of incidence? Angle between normal and incident ray. That means angle between incident ray, normal and the point of contact which is separates between rare medium and denser medium is called angle of incidence. Here the light is incident exactly normal to the surface. So no incident angle. So I is equal to 0. If I is equal to 0, what is R? We know that R sin R. Sin R is equal to sin I by n. I, this is a 0. 0 by n. So sin R also 0. So sin angle of incidence I is equal to R is equal to 0. I is equal to R is equal to 0. Angle of incidence which is equal to angle of refraction at the point of where the point light incident, the point which separates between narrower medium and denser medium. So the angle of incidence I and R both are 0 at this position. At this position. But here, not angle of incidence not equal to 0. But the incident certain angle from the point. Incident the point B deviates. The angle of incidence is not equal to angle of incidence is not equal to 0. So there is a certain angle. The refractive index of liquid is N1. Refractive index of air is N2. So N1 for denser medium or water. N2 air or rare medium. N1 represents refractive index of denser medium. N2 represents refractive index of rarer medium. We know that refractive index of the denser medium always greater than the refractive index of rarer medium. So N2 greater than N1. Refractive index of the air is always equal to 1. But any medium it is a greater than 1. Any medium greater than 1. So N2 greater than, N1 not N2. N1 greater than N2. Denser medium, N1. Always refractive index of the denser medium always greater than refractive index of rarer medium. So rarer medium for air, that's for example we are considering this air medium. Air medium refractive index refractive is equal, that is N2. N2 is equal to 1. If we any medium refractive is greater than 1 only for least for air. Least for air N1 is equal to 1 or any medium it is greater than 1. Okay. Let's see, it's a point O, incident at a point B on the surface which separate between rare medium and denser medium, they are deviated away. See, this N and N prime, this point D and O, DO and N prime, these are parallel. DO and N prime are parallel. N and N prime DO, these are parallel. See, this is drawn to the surface at the point B which is separate between rare medium and denser medium. But this is light coming from the object O which is placed at the bottom of the beaker. It travels straight at the instant normally on the surface and refracted on the same direction in the air medium. So at the point D, no deviation. At the point B, there is a deviation because light incident at point B deviate away from the normal. We know that light travel from rarer medium to denser medium, deviation towards the normal. But light travels from denser medium to rarer medium, deviates away from the normal. So this N and N prime and DO, these are parallel. So this is a O actually. But your I is placed here. I is placed here. But you are looking here object this point O, it would appear from this point. Before filled with water, you could see the object at the bottom, this position. This position actually D, original distance of the beaker, or the object is placed at the bottom of the beaker. Now, the liquid is pouring inside the beaker. The level of the object is rising. It appears to rise. not actual position, appear to rise. Now the position is I in this. So this is I. I represents image. When water is a plane, the image of the object is little bit rising. Little bit rising. So this distance called d prime. This is the apparent depth from the surface xy. This is the original depth of the beaker. This is the apparent depth of the beaker. This part is d minus d prime. D minus d prime level of the object is rising inside the beaker. But actual distance is or depth is d. D prime, the object is appear to come from this position. That's I. So if this is I, this is also I. Alternating. If this is R, what is this? If n prime and d o, these are parallel, so DIB angle, DIB is also R. This is the R. If this is R, this is also R. This is I, this is also I. It's alternating angle. Okay. From this, now we are going to calculate what is the d prime and d minus d prime. This is elevation. It's a rising upside, rising. Original position from the original position. Actually, it's not original position. It's appear to rise. Appear to rise. Okay. Now we are going to calculate the distance at d prime from Snell's law. Refractive index of the second medium with respect to the first medium is sin I by sin R. Refractive index of the second medium with respect to the first medium is equal to sin I by sin R. So this is n2 by n1 is equal to sin I divided by sin R. Now rearrange. N1 sin I is equal to N2 sin R. N1 sin A is equal to N2 sin R. It is a rearrange. We know that. See, if ray of light coming from the object incident normally at the point D which separates between rare medium, denser medium, no deviation occur. Now the incident at the point D, there is a deviation away from the normal. Deviation away from the normal. If the angle of incidence I is very, very smaller, if I is equal to smaller, I is equal to smaller, R also smaller. So I and R are smaller angle. If the angle of incidence is incident at the point DP which separate between the rare medium and denser medium, angle of incidence I is very smaller, R is also small. R is also small. If the angle of incidence I is a smaller condition, if smaller angle, any angle, sin theta could be written as a theta. If the angle is a theta, it's a very, very smaller. Sin theta is equal to theta, cos theta is equal to 1, tan theta is equal to theta. Keep always in our mind. If the angle is very, very smaller, sin theta could be written as a theta, cos theta could be written as a 1, tan theta could be written as a theta. So, sin theta which is equal to tan theta. Sin theta is equal to tan theta. If sin theta is equal to tan theta, let us consider that we are using instead of theta we use I, angle of incidence, angle of refraction. So sin I is equal to tan I. Sin I is equal to tan I. Sin I is equal to tan I. If sin R is equal to tan R. So from this equation, let us consider this equation number 1. N1 sin I is equal to N2 sin R. If theta is equal to smaller, let us consider R is also smaller. Sin A is equal to tan I. Sin R is equal to tan R. Tan R. Use, substitute N1 tan I is equal to N2 tan R. Equation number 2. Instead of the sin I, we are using the tan because the angle sin theta is equal to smaller. So theta is equal to smaller, sin theta could be written as a theta. Theta is equal to smaller, cos theta could be written as 1. Tan theta smaller, theta is equal to smaller, tan theta could be written as a theta. So sin theta which is equal to tan, sin theta is equal to theta, tan theta is equal to theta. Both are same. So sin is equal to tan value. So instead of sin, you substitute the tan value. N1 tan I is equal to N2 tan R. So now we are going to calculate tan I and tan R from this diagram. Tan R. In this right angle triangle. So this is right angle triangle DOB. DOB. Now angle DOB. Angle DOB tan I. Tan I. What is a tan I? DOB. Tan, opposite divided by adjacent. This is I, it is opposite. This is adjacent. Opposite divided by adjacent. What is opposite? DB divided by DO. DB divided by DO. So tan angle always opposite divided by adjacent. Opposite DB, adjacent DO. Similarly, tan R. Similarly, tan R. So tan R, this is R. DIB. DIB tan R. Again opposite divided by adjacent. Opposite once again DB. DIB tan R. Tan R is equal to DB. DB divided by DI. Substitute. N1 is equal to tan I is equal to N2 is equal to tan R. Tan I calculated, tan R also calculated. Now substitute N1 tan I is equal to N2 tan R. N1 tan I dB by DO is equal to N2 tan R dB by DI. Now compare dB by DO into N2, dB by DI into N2, dB and dB are cancelled. So N1 by DO, N2 by DI. N1 by DO, N2 by DI. But now once again rearrange. N1. What is a DO? DO is original depth of the liquid or original depth of the beaker. That is a D. The next, N2 is equal to N2 divided by DI. So DI is a distance, apparent distance or apparent depth. DI, that's the D prime. It's a D prime. Our aim to calculate only the D prime. Once again rearrange. N1 D prime is equal to N2 D. So D prime is equal to N2 by N1 into D. So apparent depth inside the liquid, the object appears to be seen if our eye is placed here, this much distance from the original. Original distance is D, now appears to be rise up to this distance is a D dash. So definitely D dash is lesser than D. D dash is lesser than D. If suppose N2, what is a N2? N2 is a refractive index of rarer medium. N2 air, N1 denser. If N2 is for air, N2 is equal to 1. Always N2 is equal to 1. But N1 denser. or water, n1 is greater than 1, so is equal to, let it be n, so d prime is equal to, instead of n 1, instead of n1 n into d, so d prime is equal to d by n. D prime is equal to d by n. If we want to find out the distance from the depth, from the surface, which is surface between rare medium, denser medium, object is height is d by n. Original height or original depth divided by refractive index. If the water is not placed, its height would be the original, because n is equal to 1. N. Refractive index of air, it is a 1. So d is equal to d prime. There is no apparent depth. So apparent depth could be calculated. D prime is equal to d by n. So d original depth, n represents refractive index. Only for air it is a 1. If any medium it is a greater than 1. If any liquid is a field, any liquid or any solid body is also a field, the object is appear to rise, not original, always lesser than the original depth. So d prime is equal to d by n. Okay. Now, how much distance it is elevated? So d calculated, it is a d prime, it is a apparent depth. How much it is deviated? Elevation. So from the original height is d, apparent depth is, original depth is d, apparent depth is d prime. Now how much is raised from the bottom? That is elevation. So that is a d minus a d prime. D minus d prime. So d minus a d prime. So total it is a d prime. So this part is d minus a d prime. So d prime already calculated, d by n. Take d is a comma, 1 minus 1 by n. It is elevation. Elevation could be calculated. One example, one problem. Let's see one problem. This is the beaker. Beaker now not filled with any liquid. Original height or depth is 50 centimeters or 5 meter. That's the original depth of the beaker is a 5 meter. Liquid is not pouring inside the beaker. Now the object is placed inside. So if you see the object from outside, from the air, the same height, the height of the object from this bottom of the beaker is the same height. That's a 5 meter. Now you are filling with water or any liquid or any medium whose n value is equal to 1.5. So object is placed now here. Before fill, the original depth of the object is 5 meter. Now the object, the liquid or any one of the mediums are placed inside the beaker, whose refractive index n is equal to 1.5. How much height is raised from the bottom? The object to be seen certain height from the bottom. Already this is the height, original height. Now if your eye is placed above the surface, the object is raised certain height from the bottom. How much distance is raised? Now we are going to calculate. How to calculate how much distance to be raised? Is not a apparent depth. We are not going to calculate the apparent depth. So liquid, any medium is not a field. Original height or original depth of the beaker is a 5 meter. Now the refractive index 1.5 is a field inside the beaker. Now the object is raised certain height from the bottom. Now we are going to calculate. That is called elevation. How to calculate elevation? So how much height is raised from the bottom? that is d minus d prime. D minus d prime. D minus d prime is equal to d into 1 minus 1 by n. 1 minus 1 by n. What is a d? It is the original depth of the beaker. Original depth of the beaker is a 5 meter. So 5. 1 minus 1 by n. 1 by what is the n? N represents a refracted index. Refracted index is 1.5. 1.5. Refracted index 1.5. So 5, 1.5 minus 1 divided by 1.5. 5, 1.5 minus 1. So 0.5 divided by 1.5. 5 by 50. 0.5, it is 5 divided by 15, so 3, 5 by 3, 5 by 3, it's a 1.66, 1.66, actually it is a 5 meter, now it's appeared to be 1.66, 1.66 meter, so object, it is elevation. It is elevation. If any liquid or any medium placed inside the beaker or any material, the object must be raised a certain height. Actually, it's not as a original height, it is appeared to come the object from this position. So this is called apparent depth. This is apparent depth. So apparent depth could be called by using the formula d prime is equal to d by n. So refractive index increases. Apparent depth highly depending upon refractive index. Apparent depth highly depending upon refractive index. Refractive index n for air 1 on any medium greater than 1. If medium refractive index increases, the apparent depth always decreases. If medium, it's a water is a field. Water is a field inside the beaker. The apparent depth may be certain value. It is 1 point or 1.5 meter, for example. Water is a field. If we instead of water, some other medium like a glass placed inside the beaker, refractive index of the water for water n is equal to 1.3, for glass n is equal to 1.5. N glass greater than n water. Refractive index of the glass always greater than refractive index of water. If water is a field, the height, certain height we could see, that's a 1.5. For example, if we instead of water, if we fill some other glass whose refractive is 1.5, the depth is once again decreases. Now it is a rising. It's a rising. Already it's 1.5. It may be 1.3 meter from the surface. So apparent depth always depend on refractive index. For air, it is the original distance. If any medium whose refractive index increases, apparent depth always decreases. So apparent depth highly depending upon refractive index. So if these phenomena occur only for the refraction, it is appeared to come from the light. See, if light is a place inside the water, light coming from the denser medium to rarer medium, so light deviates. Suppose if your eye is placed here, you can see the original height, original depth. If your eye is changing the position, there is changing the position of the object is up to the rising. See, the same phenomenon could be seen if your hand is placed inside the beaker which is filled with water, but your hand is not in a straight line. It may be the bending, but light coming from this object is refracted away. That is why your hand or any object is placed inside the water, not in a straight line. It looks like a bend. Because of this. That is apparent depth. So these all phenomena occur only for the refraction of light. Let's see another topic the next class. Thank you.